So again, when we talk about, let me take these off, the technology of IPv4, we understood there is a subnet mask. We understood the number can vary from 8 to 32. It can be written with a forward slash and the number of bits. It can be written in the decimal language. It can be written in the binary language, so many of them. And then we faced the technique of VLSM, the variable length subnet mask. That was when you have in your hand an IP with its subnet mask, then you can obtain the network ID that will be used between network components themselves, like routers, broadcast ID, same idea, the valid range that can be used by yourself. Now, what we took in the previous lesson was an example out of 405. So yes, what I'm about to do in this video, and perhaps in the upcoming one, is more and more examples about the VLSM technique. It has to be done in that way. Example number 2. If you ever saw an IP address that looks like 10 and then 0, 0, 0, and they informed you today that the subnet mask was 26, what should you do? Step number 1. Write it in the binary format. 1, 2, 3, 4, 5, 6, 7, 8 dot. 9, 10, 11, 12, 13, 14, 15, 16 dot. 17, 18, 19, 20, 24 dot. 25, 26. I am done with filling the subnet mask. No more bits are needed to be filled. So 27, 28, 29, 30, 31, 32. Now these two portions are actually the network portion and the host portion. Now, yes, you mentioned that in the previous video, but you didn't really say what it means. Well, if you ever called for a pizza to be delivered by your house, there are two portions in the address that you will be providing to the delivery guy. A general one, a specific one. In general, you live in that district number 5, avenue number 17, building number 1. 3 octets that are almost fixed, and they are shared with so many others. So providing these general terms or address, let's say, portions to the delivery guy will not really lead the guy to your house, to your doorstep. Is that correct? Because the final, the most specific portion was the building number. So the guy is standing, pizza, that is hot, building 10, 20 apartments. Where are you? So you need one more specific, that is the last super important thing, which is the host portion. Door number, house number, apartment number that belongs to you and only you, and it's not shared with other different neighbors. That providing this last host portion will ensure that the packet was delivered to you. Why am I saying that? When we have a domain, just like we have seen in the previous video, where the subnet mask was 24, we understood that there are 254 pure, valid, usable IP addresses. The first 3 octets were fixed over these addresses. The 192.168.0 was always there. The 4th octet was changing. So the very first computer had an IP address of 192.168.0.1. The second one, 192.168.0.2. The third one, 192.168.0.3. I am still counting and repeating for 254 times 192.168.0. In every single time, the counter is increasing and changing in the 4th octet only. Why? Because in the shadow of the IPv4 lies the subnet mask. And when the subnet mask was written in the binary format, we have seen that the locked portion is the one represented by ones. The flexible portion that can be changed is the one represented by zeros. In the previous example, it was even simpler because 3 whole portions were locked. 192 was impossible to be changed, 168 as well, 0 as well. The fourth one was to be changed. You will ask a question. Does that mean 192, 168, 1 dot something is not a valid IP? It is a valid IP. But from another network that does not see or it's not able to communicate with the very first network of 192.168.0 dot something. It is another network. We don't know them. We can't see them. We will need the routing operation and the routing protocol to see them. This is a whole another story. We are talking about addressing and designing a broadcast domain of an IPv4 block or space for a single network to communicate. Just operate a network for me today, just the LAN, local area network only. That's it. So I will understand that from increasing the host portion and keeping the network portion fixed. That is the use, the benefit of the network portion and the host portion, which I hope was clear for you. When I see an example of an octet that has a mix of ones and zeros within the octet, what does that mean? It means part of the octet is fixed, part of the octet is flexible. How? Let's see. Give me an example. All right. So let me go back to the roots and let me go back to the original method that you and I have used in the previous video in order to what? In order to derive and understand the subnet mask of 24 network. Today we have 26. So again, draw it in binary as a step number 1. I did. Step number 2 was, if I remember correctly, if I'm not forgetting, was 32 bits, all right, minus 26 bit of the subnet mask equals 6, resulting in 2 to the power of 6, which equals 64. Use a calculator at the first time, second time, third time, but in the fourth time onward, I don't think you will really need a calculator. You will remember the number, 64. So 64 is the total number of addresses. 64 is the increment range, or the increment value is the IV. Don't forget about the IV because I will be using that for the upcoming 10 examples, like 5 examples in the VLSM technique, another 5 in the CIDR technique until this course is done or finished, all right? So if I understood that there are 64 addresses, let me go back to the original rule that says 10.0 was the network ID. 10.0.0, you understand me that 10.0.0 is fixed because their shadow is filled of ones. No change, no modification, no 1, no 2, no 3, nothing. 0 is 0, 10 is 10. No changing at all. Dot 1 is the very first usable IPv4 address. Now 10.0.0. The broadcast domain. The last IP, how to reach it? Well, again, imagine I have so many fingers and I will start counting. How many IP addresses are in this domain? 64 total IP addresses. From the number of zeros, 2 to the power of number of zeros, 2 to the power of 6 equals 64. 64 total addresses. One of them is the network ID, the other is the broadcast ID. So 62 usable IP addresses are available. All right. I know from the example that the very first IPv4 was 10.0.0. .0, all right. You and I agree so far. The first one after it is 10.0.0.1. Start using from 10.0.0.1. But how to know the broadcast domain today? Start from 0 and count 64 value. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, until I reach the level of 63. Because 64 value, starting from 0 countable, will not end in 64. It will end in 63. So 63 is the broadcast domain. The IP before it, one IP before that, is 10.0.0.0. 62 a usable IPv4 address. So the range of usable IPv4s here starts from 10.0.0.1 up until 10.0.0.62, but the zeros all the way were the network ID, not to be used. The 63 was the broadcast ID, not to be used, and these were the valid range or the usable range or the usable aka valid IPv4 addresses. I hope that example number 2 had added a little bit more understanding to you. It decreased the blurry idea or the blurry image, increased more details or delivered more details to your, let's say, mind. This is very important. And there is a golden note before I end up this video, is that the network ID is always, always, always even, an even number, and the broadcast ID is always, always, and always an odd number. Yes, 0 is an even number, all right? So enjoy this example. Take a break before we start example 3 later. And this will be very important. Thank you very much.